Okay, so we'll start with chapter 6 today, class 10 maths. Okay, so here introduction and these two questions. Okay, so let us start with the introduction. First thing here, the introduction. So under your introduction, let us do an activity. Okay, you follow me. Simple activity that all of us can easily pick up. Just draw a simple circle here with a center, as denoted as figure 1, and on the right side slightly bigger you draw, but a circle still, figure 2. Okay, now look at this one here. Let us talk about the size of the two. Do the two figures have the same size? Simple question, right? Then you will say size is not same for these two figures, right? Then how about the shape? Let us look at the shape and say figure 1, what is the shape? Yes, try. Yes, that's correct. Good. That is circular, that's right. Okay. Then how about the figure 2? What would you say is the shape of figure 2? Yes, that's right. That's good. Same, circular. So we realize here that even though these two circles have different shape, different size, they have the same shape. So when this type of figures like two circles, any two circles that always have the same shape but not necessarily the same size are called similar figures. Okay, so let us write down the definition for similar figures. So write down here. Below you can write, okay, two figures are said to be similar, are said to be similar if they have the same shape but not necessarily the same size. So if two figures have the same shape, they will be similar whether or not the size is same. Okay, so let us now go to the main topic after we have done this, having done this activity. And their first question, let us do this important is what are similar triangles then? That's what is our topic, right? So we have understood what are similar figures, so this should be quite easy. Let us write it together. Two triangles are similar if they have the same shape but not necessarily the same size. So this will be our definition for similar triangles. Okay, having done that, let us now move on to one of the main things that we'll be discussing in this class, which is a theorem. Okay, now in your geometry part for class 10, some theorems we have to prove, so we'll mark them as star marks, okay, asterisks or star marks, meaning it can come in your exam as a question, so you will need to know how to prove the theorem. One such theorem is your basic proportionality theorem. So write it down, basic proportionality theorem. Okay, write along with me. Let's write the statement of this theorem. It says, if a line is drawn, parallel to one side of a triangle if a line is drawn parallel to one side of a triangle to intersect the other two, to intersect the other two sides, okay, other two sides in distinct points, in distinct points, the other two sides means the other two sides are divided in the same ratio, are divided in the same ratio. So this is the statement of the theorem. So we'll have to prove this, meaning it can come in the exam as a question. So let us do that. Let us have a triangle here, maybe a reasonably big one. This triangle, let us say, the triangle that we have taken representing a triangle for us, let us say. It is A, B, and C. Draw along with me. And let us say this line here, D, E, what theorem is saying, given parallel to one side BC, let us say. So the arrow single pointing in the same direction would mean parallel. So let us write the given. Given is, in this triangle ABC, the line DE is parallel to BC such that, write down, okay, such that it intersects the other two sides, intersects AB, that means, and SC at the points D and E respectively. So this line is parallel to one side BC and cuts the other two sides of the triangle AB and SC at D and E, right? So with this, we have to prove something. So let us write that down. Here to prove is to prove that this line divides these two sides AB and SC in the same ratio, means equal ratio. What do we mean by that? That means this line cuts this side AB into two parts, you see. So we divide those two parts, AD by DB. This is a ratio. This is a line segment divided by a line segment. So ratio means division of same type, 2 centimeter by 3 centimeters. So that's a ratio. Is equal to the other side here, AE. AD corresponds to AE and then EC. So question is saying this line will divide these two sides in equal ratio or same ratio, means this by this line that cuts AB into these two part and these two part will be, this by this will be equal to this by this, means in the same ratio. We have to prove this. So in order to prove this, let us do a construction. Construction means something we are doing extra. Let us join this here, BE, okay. Let us join BE and then DC, this one, and then let us draw here from this point one line making 90 degree. Okay, wait. So one line which is from here perpendicular. So here D perpendicular 90 degree. So DM perpendicular to AC, and from here let us draw a line perpendicular to, here you see perpendicular to AB. So EN, let us say, whatever MN, we have used MN. So with this here perpendicular, this line here perpendicular to AB, and this line perpendicular to SC. So let us do that. Join this one here DC and BE or EB, whatever, and then after that draw this one here EN perpendicular to AB, EN perpendicular to AB, and DM perpendicular to AC. So this is our construction. So let us start the proof. Proof means the answer for this here. So proof is here. I'm going to write something. So area of triangle ADE will be equal to area of triangle ADE. That's very obvious, right? A triangle area will be equal to its own area. If you want to keep a reason, then you can just say this is common triangle, same triangle you mean. Okay, now we know that area of a triangle formula is, one formula is there, half into base into height. So here for this ADE, we can write like this. Base means one side, any one side, AD let us take. Then height should be a line perpendicular to that AD, which is only this here, EN, you see. So that will be the height, half into base AD into height ED equal to half into, now this same triangle, we have taken this as base. Now let us take this side as base, AE. If you take AE as base, then the line which is perpendicular to AE is DM. So that will be the height, DM. We can get these two half cancelled, and therefore you will get AD into ED is equal to AE into DM. Let us keep this one as equation number 1. Okay, having done that, let us go to here. The next part, that is, again, you can write here area triangle. I'm going to take this, observe carefully so that you don't get confused. BDE, BDE, this one here, BDE, this triangle, the tracing of my finger here, is going to be equal to the area for triangle BDE taken. Now let's go here, CED. We will explain why. Now the area of these two triangles are equal because areas of triangles on the same base, I did on first same base, and between the same parallels, means parallel lines, are equal. Their area will be equal if the two triangles are on the same base and all between the same parallels. Now look here, this triangle DBE and CED are on the same base. They have a common base. Same base means DE is the base of this triangle, also the base of this triangle, and both these triangles BDE and CED, this here, are between the same two parallel lines, DE parallel to BC, we were given, right? That is why their areas are equal. This is a theorem, okay, that we did in class 9 also. Now having got that, now we can continue. So that will give you here area of BDE, half into base. Let us take here, this one is the base, any one side you can take, but this is more appropriate this time, BD. So right there, DB or BD, DB into, if this is the base, we have to find the line which is perpendicular to this. Now because this is here, BDE is here obtuse triangle, that means one angle is more than 190. So from here, this is the base, means you look here, the opposite vertex is from where the height will come, see, from here. This is the opposite vertex of this side DB, which is E. So from there, the perpendicular is this one. So the height is EN. This is something like this for obtuse triangle, ABC, for example. Then if you take this as the base, then we have to produce this, because the perpendicular is the height. Base into height. Base into height. Look at this portion, this triangle, and from here, height. So EN is the height. That will be equal to half into for the other triangle CED. Let us take this one EC as the base. Then the perpendicular will come from the opposite side, CED, opposite side, opposite vertex B. So CED from the opposite vertex. So opposite vertex to this side is this D, which is the perpendicular here, DM. So we write here DM, half into base into height. So having done that, let us do here half cancelled. So we're getting here dB into En is equal to EC into dm. Let's put this one as equation number 2. Okay, having done that, finally we can write here, write down dividing. Okay, this one also can be read out. Dividing equation number 1 by equation number 2. What will we get? Let us see. 1 divided by equation 2 means left hand side of equation 1, see, equal left hand side divided by the left hand side of equation 2. Then we will see En, see here, yeah, so AD, this is S by the way, so AD into ED, AD into, sorry, this one is here, we have to correct slightly here, ADE into En, see this is the height En, perpendicular, correct here, En, okay, sorry, go back and correct. The other one is okay, ADE here, this one, AE into DM, yes. Now, if you divide this equation 1 by equation number 2, then En here and En left hand side will get cancelled. So, this AD is left only divided by this here, this is cancelled, En cancelled, by dB will be equal to, then right hand side, AE into DM by, divided by EC into DM means DM will cancel and AE by EC will be left. So AE by EC. This is exactly what the theorem is asking us to prove. So hence proved. That is the answer. Okay. Now, having done that, we'll go to the next one. There's another theorem here, converse of basic proportionality theorem, but we don't have to prove, we just have to understand. Okay. So let us write down the next theorem. But no need to prove, we just have to understand. Converse of basic proportionality. Converse of basic proportionality theorem. Okay. So here we need to understand this theorem, but we don't need to prove. This is not in the syllabus to prove, just to understand and use it for solving sums. If a line divides any two sides of a triangle in the same ratio, if a line divides any two sides of a triangle in the same ratio, okay, in the same ratio, then the line is parallel to the third side. Then the line is parallel to the third side. So to understand this, let us draw a triangle. Let us say this is the triangle. What this theorem is saying is like this, ABC. If, okay, in triangle ABC, this triangle, let us say a line is there that divides two sides, AB and AC, DE. DE divides AB and, okay, intersects, you can just say, or DE cuts. Intersect means cuts AB and AC at D and E respectively, okay, respectively, such that, in this manner, okay, such that here this ratio AD by this DB, if it cuts in such a way that this by this is equal to AE by EC. That means if the line cuts these two sides in equal ratio like this, then the theorem is saying we can be sure that this line DE is parallel to BC. Basic proportionality theorem is the ulta, the reverse. DE is parallel to BC given. Then AD by DB will be equal to AE by EC. But here, AD by DB is equal to AE by EC is given. Then the line will be parallel. So this is the converse or the reverse, the converse of basic proportionality theorem. So we're going to basically use these two theorems in exercise 6.2. So let us begin. Okay, so let us go there and begin. Exercise 6.2 A1, question A1. This is on page 133. Go to open your textbook there. In the given figure, so let's write there. There's a figure given like this. You can draw along with me. From your text we are taking. There's a line here DE already parallel to BC. Then this value is given as 2 centimeter, 3 centimeter, 4 centimeter, this line DE, and we have to find this X. So given this figure, so in the given figure, DE is parallel to BC. We have to find X, how much? So there, now let us do this. Here in these two triangles, in triangles ADE. Now this is a theorem that we're going to discuss in detail before the next exercise, but from right here they have given questions, so we'll just do it. In triangle ADE, triangles ADE and ADE, or you can just write the big one first, also up to you, ADE, okay, and then this one big one, ABC. I've put here plural S, so I didn't put triangle again. If you didn't put S here, then you need to put another triangle like this. But the other way around, easier, shorter, is put the plural here, and then you don't have to mention in the next one. Okay, in triangles ADE and ABC, this angle A that belongs to triangle ADE also belongs to the big one. Therefore, they are equal. We call that one as, this angle is common to both, so they are equal, right? Then if I were to put here angle 1 for this angle inside this ADE, so angle 1 inside triangle ADE is equal to this here, angle B in the triangle big one ABC, because they are corresponding angles. We know that when two lines are parallel cut by a line, then the angle here, see, up here and up here, they are equal because they are corresponding angles. Like that, you see these two lines are parallel already given. So this angle 1 and this B are corresponding angles, and we know that corresponding angles are equal when the lines are parallel. We did these theorems in class 9 also, right? Now the one theorem is there in the next chapter. Now if in two triangles, two angles of the first triangle are equal to two angles of the second triangle, the two triangles are surely similar. Okay, so we write here in the form triangle ABC similar to triangle ADE, or you can also write ADE similar to ABC or ABC similar to AD, up to you. Okay, and this is the sign for similarity, means same shape, using AA two angle similarity condition. This is called AA similarity condition of triangle. So we can simply write it as AA similarity condition. That's enough. Now if two triangles are similar, this is the two basic properties of similar triangles, then the corresponding angles will be equal, corresponding sides will be proportional. I repeat, corresponding angles will be equal and corresponding sides will be proportional if the triangles are similar. And since the two triangles are already similar, we want to take the sides. Corresponding sides will be proportional, means, you see, corresponding means first two letters, what are they? AB, yes, will be divided by first two letters of the second triangle AD. So that is one ratio. taking one side each of the two triangles. Then second and third letter, yes, that's right, BC. By what are the second and third? DE. That is called corresponding, okay? What we mean to say is second and third letter BC and first and third are not corresponding. Second and third, like that, okay? Then what are the first and the third letter? Because there will be three ratios possible, right? Very obvious because every triangle has three sides. So first and third letter SC. So we write that SC by first and third letter in the second triangle AE. So that is what we meant by corresponding sides. And corresponding sides, don't write this, just listen, are proportional. The word proportional means the word proportional means ratios are equal. I repeat, proportional means ratios are equal. So these three ratios, if you put equal sign between them, then they are called proportional. Proportional means equality of ratio, or two ratios or three ratios are equal to each other, then they are called proportional, okay? So this is why we did this, is because we know we have to give reason. Corresponding sides of similar triangles are always proportional. Proportional means these three ratios, equal sign will be there. Proportional means equal sign will be there. So we'll just take out which ones we need. I think we need this here, AD. So this one, AD. AB also, so this one. And then here, DE1 we need, this one. And BC. There is no value given for AE and AC, so we just don't cut, but we don't take that. We do take these two. Then we write here AB by AD is equal to BC by DE. You can just select any two we need, right? So we need these two in this case. So AB, if you look here, AB is here. Okay, AB is AD plus DB. I think you will agree with that. See here, AB is AD plus DB by AD. Just keep it for one time. BC, you can write BC here. We can just write it as X. And DE here, already given, so 4 centimeter. So let us deal with this part. AD, as you can see in figure, is 2 centimeter. DB is 3 centimeter. Divided by AD here. Divided by AD. So AD is here 2. So we write here 2 centimeter is equal to X by 4 centimeter. So just a matter of doing slowly. Now here 2 plus 3, 5 by 2 centimeter. So we know this 2 centimeter will cancel. X by 4 centimeter. So keep X, don't move that, and shift this. 5 4s are. Or you can just shift without multiplying also. 5 into, then this 4, if you shift down, will go up. So 4 centimeter comes up, divided by here down 2. So 2 2s are 4. So you're going to get here this X equal to 5 2s are 10 centimeter. So the value is 10. Now in the answer choice, this is a multiple choice question. We see that the answer that matches this is choice number 4, which is in your textbook, you can see, which is 10 centimeter, right? Okay, let us go to the last question before we conclude this class. A2. So A2 you write down. Okay, A2 is, in the given figure, the value of X for which DE will be parallel to BC. So let's draw the diagram first. Diagram looks something like this. So let us draw that together by looking in the textbook. This labeled as A, B, C, and here D, E, and this is given parallel to this. This is X plus 3 units, and this one is 3X plus 19. This one is X, and this one is 3X plus 4. This portion. So let us solve this. So here, given to us here is, right, in the figure, or as the textbook is saying, in the given figure, we know that DE is parallel to BC given. Now you have to find the value of X. So here, X is question mark. Now let's do like this. In the triangle ABC, the big one, here, this ABC, this line here, DE, is parallel to BC, because this is given to us in the question. So we write the given. Right? So just now we did basic proportionality theorem that if a line is parallel to one side of a triangle, then that line DE will divide the remaining two sides AB and SC in equal ratio. Means this one here we learned from a basic proportionality theorem, AD by DB will be equal to AE by EC. And reason for this is using basic proportionality theorem. So we can write that down. Okay, so once we're done with that, then that implies AD, if you see here, is x plus 3. So we write that by, if you want, bracket, otherwise it's okay, DB is 3x plus 19 is equal to AE here, x divided by, 3x plus 4. Now let us cross multiply them. So that gives me, cross multiply means up and down. Okay, so x plus 3 you can multiply to this one, 3x plus 4 will be equal to, after equal, down and up or up and down. So x into 3x plus 19. I hope you got that right. So next here we'll multiply binomials. See, x, take this and multiply these two first. Plus into plus, plus x into 3x, 3x square, plus into plus, plus x into 4 is 4x. Now next, go to the next, plus into plus, plus 3 3s are 9x, plus 3 4s are 12. So that is finished. Right side, x into 3x is 3x square, plus x into 19 is 19x. So immediately we see that if you shift this plus 3x square to the right side, it will become minus and become, cancel this 3x square 0. 3x square minus 3x square minus 3x square 0, right? So we may as well cancel it here itself. So that gives you here, just keep this number alone, and then here 19x, these two here at how much? 4 plus 9 is 13x, plus 13 go that side becomes minus 13x. So this will become here, that implies 12 will be equal to 19 is bigger, write it up, smaller is 13. And so no sign in front here means plus, here in front is minus, so we put there. So if you subtract this, we're going to get here 9 minus 3 is 6, and upper bigger number sign is plus, so that's same plus sign will go here. So this is 6x plus 6x. So one more step before we are done. So here we can come. So that gives you x, don't move that x. This 12 also don't move, and if you shift this 6 to the left side, it will come down, right? So 6 2s are 12, so x is equal to 2. Now the answer choice that match this one there, the question is number 4 again. So we write there 4, which is having 2 value. So this concludes the portion for this test. You can go and give test 6.2A. Okay.